Listen it carefully, it's very important, and that is reverberating circuit. If we say reverberating circuit or echoing circuit within, say, reverberating, it's kind of echo. Like, say, if you go somewhere and shout it out, and after a while, right, after a while you will hear your echo. So that is important point over here. After a while means it takes some time. So if we, in the coming classes, we will talk about what are the functions and what will happen if there is a cerebellar lesion. So one of the function is very important, is like it helps in fine tuning. So I will try to demonstrate. See, like this one, if you do alternate and faster supination and pronation, you can do it, right? A normal person can do it. This is called as diadochokinesia. 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 Kinesia is movement. Di-do to deco. If there is any lesion within cerebellum, then either it will be absent, then it is called as adiadochokinesia, means that person won't be able to do supination and pronation alternatively at a fasting pace, or he or she will be able to do it, but sometime he will, like, say, stop over some time or take some time, or sometime twice supination, one pronation, like this way. That is called as a dysdiadochokinesia. Okay, dysdiadochokinesia. That is, like, to elicit this clinical sign, person will always, like, the physician will ask the person to do supination pronation faster, or sometime, like, putting the hand, like, say, imagine this is the knee, then like over the knee itself, the same hand. So this process, the supination and the pronation faster, at a faster pace, this happens because of the cerebellum. At the starting of this lecture I said cerebellum is concerned with fine tuning the movement. So how this diadochokinesia is happening, this one we will cover in this cerebellar circuit. So this circuit is echoing or reverberating circuit. See, like in the previous slide I said there are the two ascending fiber. One is the climbing fiber, other one is the mossive fiber. And climbing fiber, mainly it was going to the Purkinje cell, right? Ma ka ladla. Mother is climbing, ladla is Purkinje cell. Okay. And Mosi was the father. And who was the sweetest child for the father? Granule cell. Father was fond of granule, सबसे छोटे वाले का. Okay. So forget about other cells. We will just keep in mind the climbing and mossy fiber, Purkinje cell and granule cell. Okay. Suppose a person has, the person's brain has ordered to perform supination for pronation. Okay. Physician asks the patient to perform supination and pronation. So what he will do, his brain, cerebral cortex, it will send the fibers to, say, corticospinal tract. Via the corticospinal tract, the cortex, I'll rub it off, these feed forward inhibition, feed backward inhibition, this is important. Cortex will send a copy via the corticospinal tract to the spinal cord. It also sends one copy to the cerebellum, right? And via cerebellum it goes over there. And cerebellum was also receiving a feedback copy, right? Now, this first supination process is performed. Supination is performed. So this blueprint that's coming from the cortex, just consider it is coming from where it will come? It will come via the climbing fiber. Climbing fiber was coming from inferior olivary nucleus within the medulla. So from the cortex, the corticospinal tract are going, it will go to the inferior olivary nucleus, and via the climbing fiber, what it will do? Via the climbing fiber, this corticospinal tract, we just consider climbing fiber number 1. It will stimulate PC1, right? Because the climbing fiber directly communicates one to one with the Purkinje cell. Now what the Purkinje cell will do? It will send the signal to deep cerebellar nuclei, inhibitory, right? It is the inhibitory. But output from the deep cerebellar nuclei is always excitatory. It will go downward toward the muscles. Okay. Now the order has been sent to the muscles of the supination to perform the supination, right? Now as soon as the supination happens, what kind of a sensory receptor will get stimulated? Those proprioceptor, right? And because of the stimulation of the proprioception via the ascending track, that copy which is supposed to come back to the cerebellum via ascending track, it will enter to the cerebellum through the Morse fibers. Morse fibers, apart from the inferior olivary nucleus, all the connection to the cerebellum was happening through the Morse fibers, right? So that come back is stimulating, just imagine, say our Morse fiber 1. Okay. Now what the Morse fiber will do? It will stimulate granule cell 1, right? It will stimulate granule cell 1. Now if we recall back the feed forward inhibition and feed backward inhibition, what was the significance? जो मैं आपको बता रहा था ना कि control में रखते हैं. So what does that control means? When the climbing fiber is stimulating the Purkinje cell, it is very short-lived. By the time this feedback comes back via these Morse fibers to the granule cell, the already excited Purkinje cell has come back to the resting condition. See, I will repeat it. Supination order goes down to the muscles for the supinator muscles to perform the action, and it sends one copy via climbing fiber to the Purkinje cell 1. Now what will happen to the Purkinje cell 1? It will get stimulated. Now supination will be performed. Proprioceptor in the arm, they will send the signal back via the ascending fiber, and that copy will enter to the cerebellum via Morse fiber. Morse fiber in turn will stimulate granule cell. Now what is granule cell doing to the Purkinje cell? It will stimulate, right? It will stimulate the Purkinje cell 1. So the first stimulation of the Purkinje cell has been vanished by the time this second stimulation in the same pathway of the Purkinje cell 1 is happening. See, आपने echo point पे जाके shout किया, that is, आपने shout किया, बंद हो गए, that is the first stimulation of the Purkinje cell. Now वो shout कर दिया उसने, it is coming back via this pathway और echo दोबारा सुनाई दी है. So there is a gap, right? Gap between the original voice and the echo voice. So that's why this is the echoing circuit. Now by the time this echo is stimulating the Purkinje cell 1, what is happening to the brain? Brain has been ordered, it has planned and programmed to perform continuous supination and pronation. So by the time this echo is stimulating Purkinje cell 1, the pronation signal is going the same pathway. Now just imagine this, I will represent it with the other color, the green one. The pronation is stimulating the climbing fiber. Just imagine that is climbing fiber 2, right? Now what the climbing fiber will do? It will stimulate the Purkinje cell 2. We will depict it over here. Purkinje cell 2, right? So by the time Purkinje cell 1 is getting stimulated from the echo, it will almost coincide with the direct stimulation of Purkinje cell 2, right? Did you get it? Like the Purkinje first supination process, stimulate the Purkinje cell 1, it performs the action, again it gets stimulated by the echo. By the time the echo is coming back, the second order has come for the pronation and it has stimulated the direct stimulation of the Purkinje cell 2. It's very, that's why it is like very at a faster pace. तभी तो दिक्कत होगी. So by the time this second Purkinje cell is getting stimulated, direct stimulation from the descending tract for the pronation, the first Purkinje cell is again getting stimulating via the echoing circuit. So it almost coincide. Now just imagine what will happen for the Purkinje cell 2. The same process will be repeated. It will send the signal, the pronation will happen. Now the pronation will, via the Modi fiber 2, it will stimulate granule cell 2, right? It will stimulate granule cell 2. Now the granule cell 2 will again stimulate the Purkinje cell 2. Now by the time Purkinje cell gets stimulated through the echoing circuit, the first signal was supination, second is pronation. What is the next? Supination again. The third signal, direct stimulation of the Purkinje cell 1, will happen via direct communication from the cortex for the supination. So did you get it? Like say if I try to draw it, we can say Purkinje cell 1 was for supination, Purkinje cell 2 was for pronation, that is direct stimulation. Now what was the second part? Second part was Purkinje cell 1 was getting stimulated back. This purple is echoing circuit via echo circuit of the supination. And what is the significant part over here? Significant part is when the Purkinje cell gets stimulated via the echoing circuit coincides with direct stimulation of the PC2. Okay, so supination, pronation, then what was the third? Supination again. Supination, pronation alternatively. So this PC2, when it gets stimulated via echoing circuit, what will happen with the PC1? PC1 will again get the direct signal, direct stimulation of the PC1. So we can say the direct stimulation of the PC1 will coincide with echoing circuit of PC2, and similarly direct stimulation of PC2 will coincide with echoing circuit of PC1. So if we cut off this part, cerebral communication, cerebral cortex communication, we can say when we need direct stimulation of the PC2, the PC1 echoing stimulation is happening. So if there happens a communication between PC1 and PC2, they automatically will keep on stimulating each other via the echoing circuit, right? So that synapse strengthens once this process is started, and then there is no need for the cerebral cortex communication. So cerebral cortex will just initiate supination and pronation, and then it will leave it for the cerebellum to continue that process via the echoing circuit, right? It's kind of a load shedding of the cerebral cortex, because cerebral cortex has got so much other things to do. It will just initiate and will hand it over to the cerebellum to perform this movement. So if there is any lesion within the cerebellum, the person won't be able to perform alternatively antagonistic muscle movement, pronation, supination. That's called as Diadochokinesia, or if there is abnormality, then it's called as Diadochokinesia. A means total absence. So that's all about the reverberating circuit.